what is a donkey car and how does it work? How do you collect data and how do you train a model? A lot with natural language understanding in this software called Dialogflow. It's a Google-made framework where you can train a voice bot to help solve problems. So it's about creating voice interfaces to anything, really. So if that's something you have interesting, feel free to ask questions about that after the show, I guess.
About three things which are very general for machine learning, and that is the machine learning models, and also the data, and model training and evaluation. So basically, when you're training a machine learning model for any case, could it be like specifying what kind of toilet you're using or driving a car around the track, then choosing the model can be very important. Basically, you need to think about, like, some models can be good for certain problems. Some examples of these are recurrent neural networks that work very well with language modeling. If someone have heard that before, that is basically a neural network which uses the previous output as an input for the next step in training. So basically, when you're talking, the meaning or the context is very important for the meaning of the current word that you're speaking. So that, and then, for example, convolutional neural networks have been shown to work very well for images, which is also being used with the models for the donkey cars. So basically, differences in what input do you have and how does the network or the neural network look, which is just one thing of machine learning, and also the output. How do you want to model the output? For example, with the donkey cars, you're modeling what is the throttle and what is the steering when you're seeing this current picture. For the donkey cars, they have given a lot of is data. Data is the core of machine learning. Basically, if you're working with machine learning professionally or just in your free time, then gathering and preparing data is, in most cases, the vast majority of like what you will do when you're training a model. And also, preparing data is very important in this case, because just gathering raw data might not work very well. That comes in that you have good and bad data. Like, some data can be messy. You can have a lot of statistical noise. For example, we could have Martin be driving off the track, and the donkey car actually allows you to delete previous pictures taken when you make a mistake. But one thing that might have been good if you actually had data that showed the car going back on the track, then the car might be able to, when it failed, get back on the track in good time. Also, different data is very important. For example, we see it with our case where we are only training the car in driving one direction around the track. That wouldn't work on a different track or when it's driving just the other way around the track. This also means that usually you can have overfitting if you don't have a lot of different data. Also, just about gathering data is also very important. In our own experience, we tried attaching the camera at a bit higher angle and turning the camera more downwards so that it would see the track more and not have other things in the picture of other people. Also, I've read that polarized lenses might also work very well if you read blogs about donkey cars out there. And the last thing I'm going to talk about is like model training. So some of you might know about these different things I'm talking about here. Like, you need to test different parameters. Like, we only tested some parameters that we know worked for this track. But in general, you should, when you're training a machine learning model, you should try and do some evaluation on what does the learning rate do, which optimizer to use, using something called early stop that I was talking about earlier. And also dropout is a very often used thing to mitigate overfitting. I'm not going to really go into all these different things about machine learning, so because it can get very technical and very boring. One thing that's also interesting is that donkey cars actually allow us to use a simulation to train a donkey car. If you don't have the money or the time to get a physical donkey car like we have, I have the link in here. If you want to try it yourself, we haven't tried it ourselves, so we can't really help you with using, but you might be able to find a way to do it, and that could be interesting. Let us know if you get it to work.
I actually have a comment here because we tried a different department in Trifork tried to use another device than the Raspberry Pi. They used the Jetson Nano instead, which has a dedicated GPU. They struggle a bit with it, but I think that's a very good approach to get some more processing power if you want to train on the devices. But we didn't try to train on the device because it didn't make any sense.
Yeah.